I'm Ramya Devi, working as Assistant Professor in SNS College of Engineering. Today I'm going to share a small article regarding supervised learning. So supervised learning is a study of machine learning in which supervised ML algorithm is a type of machine learning technique that can be applied according to what was previously learned to get new data using labeled data and to predict future events or labels. In supervised learning, we give it a set of training data that the model learns from. It can then infer relationship between the features and then categories that we want and apply that to unseen new values and predict information about them. In supervised learning, models are trained using labeled dataset where the model learns about each type of data. Once the training process is completed, the model is tested on the basis of test data and then predicts the output. So these are the types of supervised learning algorithms. One is linear regression, logistic regression, naive-Bayes classifiers, decision trees, random forest, and support vector machines. So the naive-Bayes classifiers. The Bayes theorem is a mathematical formula for calculating conditional probability in probability and statistics. In other words, it's used to figure out how likely an event is based on its proximity to another. Simply put it in a way of calculating conditional probability. The probability of A given B is equal to the probability of A times the probability of B given A over the probability of B. The key insight is that the probability of something that depends on B depends very much on the base ability of B and A. The example of spam filtering. Let's just figure out the probability of an email being spam given that it contains a word free. So the probability of an email being spam given that you have the word free in that email works out to the overall probability of it being a spam message times the probability of containing the word free given that it's spam over the probability overall of being free. So the formula of the probability of an email being spam would be probability of spam of free is equal to probability of spam, probability of free of spam and divided by probability of free. So here the one more algorithm of supervised learning is decision tree. A decision tree employs a structure of test points called nodes and branches which represent the decision being made. A node without further branches is called a leaf node. The leaf nodes return class labels. Decision trees have two varieties. One is classification trees, another one is regression trees. Classification trees usually apply to output variables that are categorical, often binary in nature, such as yes or no, purchase or not purchase, and so on. Decision trees, on the other hand, can apply to output variables that are numeric or continuous, as the predicted price of a consumer good or the likelihood a subscription will be purchased. Next is the decision tree algorithms. Multiple algorithms exist to implement decision trees and the methods of tree construction vary with different algorithms. Some popular algorithms include ID3, C4.5 and CART. So the ID3 algorithm is one of the first decision tree algorithm and it was developed by John Rose Quillen. Let A be a set of categorical input variables, B be the output variable or the predicted class, and T be the training set. ID3 follows the rule. A branch with an entropy of 0 is a leaf node and a branch with entropy more than 0 needs further splitting. It uses entropy and information gain to select most informative attribute. Next is C4.5. The C4.5 algorithm introduced a number of improvements over the original ID3 algorithm. The C4.5 algorithm can handle missing data. If the training records contain unknown attribute values, the C4.5 evaluates the gain of an attribute by considering only the records where the attribute is defined. Both categorical and continuous attributes are supported by C4.5. For the corresponding records of each partition, the gain is calculated and the partition that maximizes the gain is chosen for the next split. The ID3 algorithm may construct a deep and complex tree which would cause overfitting. So next is CART. CART is classification and regression trees is often used as a generic acronym for the decision tree, although it is specific implementation. Similar to C4.5, CART can handle continuous attributes. Whereas C4.5 uses entropy based criteria to rank test, CART uses the Gini diversity index defined. Whereas C4.5 employs topping rules, CART constructs a sequence of subtrees, uses cross validation to estimate the misclassification cost of each subtree, and chooses the one with the lowest cost.